The number everybody in the auto industry has been watching for 30 years is 41, not 41 miles per gallon, not 41 horsepower, 41%. That is the thermal efficiency of Toyota's best hybrid engine, the one inside the Prius, the number that made Japan the undisputed king of fuel economy and made every other automaker look like they were still solving a problem Toyota had already solved. For 3 decades, that number sat at the top. Nobody touched it. Nobody came close. And most people inside the industry had quietly accepted that 41 was probably as high as a production car engine was ever going to get. They were wrong. And the company that proved it wrong is not one most Americans have ever heard of. In April 2026, at the Beijing Auto Show, a Chinese automaker called Geely stepped onto a stage and announced a thermal efficiency of 48.41% in a mass-produced engine. Guinness World Records independently verified the number. They also verified a second record on the same day, a fuel consumption figure of 2.22 liters per 100 kilometers in a production sedan, which translates to roughly 106 miles per gallon. 2 world records, 1 car program, 1 company that most people in the United States cannot name. And here is the part that should make every executive in Detroit and Tokyo genuinely uncomfortable. Geely does not just sell cars in China. It owns Volvo. It owns Polestar. It owns Lotus. It holds a major stake in Mercedes-Benz. The technology that just broke every benchmark in the history of internal combustion engineering is already on a roadmap that leads directly to dealerships in America. The question that nobody in the mainstream press is asking is this: how did a Chinese company that started making refrigerator parts become the most technically advanced hybrid engineering operation on the planet? And what does that mean for every car you can buy in the United States right now? To answer that, you need to understand what thermal efficiency actually means, because it is not a marketing number. It is a physics number. When fuel burns inside an engine, most of that energy does not move the car. It escapes as heat through the exhaust pipe. More of it gets lost to friction between moving parts. The efficiency rating tells you how much of the fuel's total energy actually becomes useful mechanical motion. A standard gasoline engine in the average American car converts somewhere around 25 to 30% of its fuel into motion. Everything else, roughly 70 cents of every dollar you spend on gas, disappears as heat into the atmosphere. Toyota's dynamic force hybrid engine, the one inside the Prius, does better than that. It sits at around 41 to 42%, which is why the 2024 Prius gets an EPA estimated 57 miles per gallon combined. That number made the Prius a cultural symbol of fuel efficiency, and Toyota built an entire identity around it. For decades, 41% was the mountaintop. Getting an engine to extract more useful energy from fuel than that was considered, by many engineers, to be effectively impossible in a car you could actually manufacture and sell at scale. Geely hit 48.41%. Guinness came in, ran the tests, and put it in the record books as the highest thermal efficiency ever recorded for a mass-produced internal combustion engine in history. To put that in the kind of context that makes the number visceral rather than abstract, consider where else you find engines running anywhere near that level. Formula One engines, the most technically advanced, most expensively refined internal combustion machines that human beings have ever built, run at around 50% thermal efficiency. Teams like Mercedes-AMG F1 spend hundreds of millions of dollars year over year pushing those numbers by fractions of a point, using exotic materials, operating at conditions no road car could survive, with fuel systems and tolerances that belong in aerospace. Geely's production engine, the one going into cars that regular people can buy, is now within 2 percentage points of an F1 power unit. That is not a small achievement. That is an engineering category shift. Now here is something that the source video did not fully address, and it is the detail that changes how you understand the whole story. Geely did not just stumble into this number. The progression was deliberate and relentless. In 2021, their best thermal efficiency figure was 43.32%, itself a global benchmark at the time. The BHE-15 engine platform pushed that to 46.5%. Then full domain AI integration brought it to 47.26%. This year, they cracked 48.41% through what they call a wind-ride tornado combustion system, which optimizes the mixing of fuel and air inside the cylinder and refines combustion control to extract the maximum possible energy from each ignition event. Each step in that progression was a record. Each one took the industry further into territory it had never mapped before. This was not luck. It was a sustained engineering campaign with a specific target, executed year over year with the kind of focus that Western automakers redirected toward electrification and left sitting on the table. The engine itself is called the BHE-15. It is a 1.25-liter four-cylinder, which on paper sounds like something you would find in an economy rental car. That is deliberately disorienting. What Geely did with that small displacement is pair it with a system they call the IHEV, or Intelligent Hybrid Electric Vehicle Platform. The electric drive unit in this system delivers 230 kilowatts, which Geely claims is 1.72 times the output of typical Japanese hybrid motors. The whole system is managed by an AI platform they call AI Cloud Power 2.0, which monitors ambient temperature, road incline, humidity, battery charge levels, and engine load in real time, and continuously adjusts the ratio of electrical to combustion power delivery to keep the engine operating near its peak efficiency window as much as possible. Under standard driving conditions, the electric motor carries the workload more than 80% of the time, meaning the combustion engine only runs when the system can guarantee it is burning fuel at near maximum efficiency. The engine operating time is reduced by more than 27% compared to conventional hybrids. That is the mechanism behind the number. The AI is not a feature. It is the reason the efficiency figure exists. When they took the Geely Emgrand IHEV to a test circuit in Hainan, China, and ran it through a standardized efficiency test, the car consumed 2.22 liters per 100 kilometers. At American scale, on a standard 1.5-gallon tank, that is roughly 1,590 miles of range. You could drive from Los Angeles to Denver and back on a single fill. For comparison, the 2024 Toyota Prius, which gets 57 miles per gallon on the EPA's combined rating, would give you about 855 miles on that same tank. And this is not a concept car that Geely rolled out on a velvet platform and then sent back to the lab. The IHEV system is already entering mass production. Pre-sales for 2 Geely models carrying this platform began in April 2026. The system is scheduled to roll out across the Emgrand, Boyuel, Xingrui, and Xingyuel throughout this year. This is a production rollout happening right now. Here is where the story stops being about a Chinese car company and starts being about something that every American car buyer needs to understand. Geely is not a company that sells cars in China and then watches from a distance as the rest of the world drives something else. Geely Group's portfolio reaches directly into the American market through brands that carry zero association with China in most consumers' minds. Geely acquired Volvo cars from Ford in 2010 for $1.8 billion, a transaction that was stunning not only because of the price, but because Ford had originally paid $6 billion for Volvo, and a company most Western observers had dismissed, as a regional Chinese automaker walked out of that deal with a European institution. In 2018, Li Shufu, the founder of Geely, acquired a 9.69% voting stake in Daimler AG, the parent company of Mercedes-Benz, making him one of its largest individual shareholders. That stake cost approximately $9 billion and was assembled in secret over months through investment structures that stunned the global financial press when they became public. Geely also owns Polestar and Lotus, and operates a 50-50 joint venture with Daimler that produces smart vehicles as a global electric brand. The powertrain licensing entity connected to Geely, called Horse Powertrain, licenses engine technology to other automakers internationally. The man behind all of this, Li Shufu, was born in 1963 inches a farming village in Zhejiang province. He borrowed approximately $3,000 from his family in 1986 and opened a factory making refrigerator components. By 1994, he had moved into motorcycles. In 1997, he announced he was going to build cars. He had no manufacturing infrastructure for it, no engineering pedigree in automotive, no major investors, no industry connections. When reporters asked him how hard it was to build a car, he reportedly said that a car was just 4 wheels and 2 couches. The industry laughed. In 2001, Geely became the first private Chinese company ever licensed to manufacture automobiles in China. In 2007, he wrote a letter to Ford offering to buy Volvo. Ford ignored him. He showed up at the Detroit Auto Show in 2008 and tried again in person. Ford brushed him off again. He came back in 2009 more prepared. In 2010, he walked out of Ford's headquarters with Volvo. The farmer's son, who was laughed at for thinking he could build a car, is now one of the largest shareholders in Mercedes-Benz, and his engineering team just built the most thermally efficient production engine in the history of the automobile. That is the company the American auto industry is now trying to figure out how to respond to. The context in which Geely built this engine matters as much as the engine itself. While the American conversation about the future of transportation has been almost entirely consumed by the binary choice between internal combustion and full electrification, Chinese automakers as a group have been executing a third path that most of the Western automotive press has not adequately covered. BYD, which already surpassed Tesla in total global electric vehicle sales, released its 5th-generation hybrid system in 2024, achieving efficiency figures well beyond what Toyota or Honda have managed. Other Chinese manufacturers, including AITO, Changan, SAIC, GAC, Chery, and Great Wall, have all released vehicles with combined ranges exceeding 2,000 kilometers on a single tank and charge within the last 18 months. These are not future promises. They are cars on sale now. Meanwhile, the EPA's own data shows that the average new American vehicle sold in 2024 achieved about 27 miles per gallon across the fleet, and that number only reaches that level because electric vehicles pull the average up. Strip out the electric vehicles, and the combustion fleet average drops to roughly 25 miles per gallon. The gap between where Chinese hybrid engineering is operating and where American mainstream vehicles are operating is not a competitive disadvantage anymore. It is a generational difference in ambition and execution. The practical implications of this for an American driver are not abstract. They are arithmetic. The average American household spends somewhere between $2,000 and $3,000 a year on gasoline, depending on how much they drive and what they drive. At 106 miles per gallon, that number does not just decrease, it collapses. A car that gives you 1,590 miles from a 15-gallon tank means filling up roughly once a month instead of once a week for a typical driver. That is not a marginal efficiency gain. That is a structural change in the relationship between a household and its fuel costs. And unlike a battery electric vehicle, it does not require a home charger installation, which can cost between $1,000 and $3,000, depending on the electrical situation in your house. It does not lose 30 to 40% of its range on a cold January morning in Minneapolis. It does not carry a potential battery replacement bill of $10,000 to $20,000 somewhere in its future. You fill the tank, you drive. You barely use any fuel doing it. The reason this matters to the channel's core argument is that it exposes something the American auto industry has been quietly doing for decades. It stopped engineering for efficiency and started engineering for margin. The internal combustion engine in the average American car has been largely unchanged in its fundamental thermal performance since the 1990s. The EPA data shows it. The gains that have been made in fleet economy have come overwhelmingly from hybrid and electric additions to the mix, not from making the combustion engines themselves dramatically better. Detroit made a calculated decision that American consumers valued horsepower and truck bed size more than they valued efficiency, and for a long time that calculation was correct and profitable. The result is that when a company from China arrives with an engine that operates at nearly 50% thermal efficiency, American manufacturers have nothing in their current pipeline that competes with it. That is not an accident. It is the consequence of 30 years of engineering priorities shaped by boardroom economics rather than combustion physics. The system that will determine whether this technology reaches American buyers is already in motion and is further along than most people realize. Geely's IHEV architecture supports 1.5-liter, 1.5-liter turbocharged, and 2.0-liter engine variants, all paired with the 1-in-1 electric drive unit. That flexibility means the platform can be adapted to a range of vehicle sizes and segments. Volvo's product roadmap for the next several years will be influenced by the engineering capabilities now sitting inside the Geely Group. The same applies to the vehicles produced under the smart joint venture with Daimler. The decisions being made in Hangzhou right now are going to determine what is under the hood of cars sold in Chicago, Houston, and Seattle before the end of this decade. That is not speculation. It is the logical consequence of corporate structure and technology licensing that is already in place. The industry framing that hybrids are a bridge technology, a temporary stop on the way to a fully electric future, was never really about the technology. It was about the investment roadmap. If you have committed $30 billion to retooling your factories for battery electric vehicles, you have a strong institutional incentive to describe hybrids as obsolete. But an engine that operates at 48.41% thermal efficiency, verified by Guinness, paired with an AI-managed electric drive system that runs on electricity 80% of the time without ever needing a plug, challenges the assumption that full electrification is the only technically credible path forward. It is not a bridge. It is a destination that happens to also be compatible with where most of the world's existing energy infrastructure actually is. There are 4 things worth understanding and repeating from all of this. First, thermal efficiency is the number that matters. When someone tells you a hybrid gets good mileage, ask what the thermal efficiency of the engine is. That number tells you how much engineering actually went into the powertrain versus how much the marketing is covering for mediocrity. Second, the brands you trust do not always tell you who built the technology. Volvo, Polestar, and Smart all carry Geely Group technology. The badge on the front of the car is not the address of the engineering lab. Third, a car that gets 57 miles per gallon was the ceiling until April 2026. It is not the ceiling anymore. The standard has moved, and any manufacturer that does not acknowledge that is not being straight with you about where the technology actually is. Fourth, the companies that spent the last 10 years dismissing hybrid development as old news now have to respond to a production engine that is within 2 percentage points of a Formula One power unit. That response is going to take years and billions of dollars, and consumers will feel it in the quality and performance of the vehicles they are offered while that catching up happens. The future of driving was not decided in Detroit. It was not decided in Tokyo. It was decided in a room in Hangzhou by engineers who had been told for 30 years that 41% was the ceiling, and who apparently did not believe it. If this kind of engineering reality check is what you come here for, subscribe and turn on notifications. The next time a record gets broken in an industry where everyone assumed nothing could change, you will want to already be here.